And good morning, welcome to your Monday's maths lesson. I hope all of you had a fantastic weekend. Today we're going to be looking at equivalent fractions, and just to start off with, I'm going to remind you about what a fraction is. Now, a fraction is made up of two parts. We have our numerator at the top here, and we have our denominator at the bottom. As it says on the screen, numerator are the number of parts that we have in our fraction. That could be shaded, or how much it tells us, or maybe how much we've eaten or not eaten. And then the denominator is the total number of parts in the whole of the fraction. Very key information, lots of vocabulary that I'm going to be using today. And for our first question today, we need to write the fraction represented by the shaded parts of the images. First of all, it's really easy to work out your denominator, so that's your bottom number. All we need to do is count the whole of this shape here. So we've got one bit there, 2, 3. So our denominator first one would be 3. And for our bottom shape down here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 here. Now for our numerator, that's the part that for this is shaded, and for that it's this one here. So that's just one part shaded. For our bottom number down here is all 3 of these are shaded. 3. So our top fraction is 1/3, and our bottom fraction is 3/9. And for our next question, we asked true or false. The shaded images represent equivalent fractions. Now, for this question, if you've got a ruler at home, it's going to be really, really helpful for you. Or my trusty piece of paper, like I used last time in one of my previous lessons I did during distance learning. Now, for this, to really help with this, just you can get your piece of paper if you're working on paper or working on computer screen. All you need to do is hold it up to that top image there and see if the shaded areas line up. That's how you can tell there are equivalent fractions. So with this, with my piece of paper, this tells me it's not an equivalent fraction. Now, if you don't have a piece of paper or a ruler, you can still work out with your maths and using your skills here. So working out this top fraction first. So we've got 1, 2, 3, 4, 5, 6. So our denominator is going to be 6, and the shaded parts are 4. And our second number here is 1, 2, 3, 4, 8, 9, 10. I'm just going to double check that. 6, 7, 8, 9, 10. Yeah, perfect, 10. And the shaded fraction of it is 8/10. Now, when trying to find equivalent fractions, you need to do the same. So if you're timesing or dividing, to your numerator as you would to your denominator. So start off with, I know that 8 divided by 2 is 4. So if I've done that to my numerators, I need to do that to my denominators. So I need to divide 10 by 2, which is not 6, would actually be 5. So an equivalent fraction to 8/10 would be 4/5. I could also, let's get rid of numbers here. I could also say do times 2. So 4 times 2 is 8, just doing the inverse of dividing there. We could times 2 here, doing the same for both our numerator and our denominator, which would actually make it 12. So 8/12 is an equivalent fraction to 4/6, not 8/10. So this question would be false. And for this question, I would like you to do it first at home before I explain to you how I got to the answer. You can use a piece of paper, ruler, or the method that I previously showed you on the other slide. So this question is asking us here, which two fractions are equivalent to each other? We've got A, B, or C. Now to help myself, to really work this out, I would write each fraction out just next to it here so I can visually see what each fraction is. So first of all, we've got A here, which is 1, there's only one part shaded, and our denominator would be 4, because our whole there is 4. The whole part is 4. Next we have B, 2 parts are shaded, and it has 6 in total. Finally, C at the bottom here, there are 3 parts shaded, and let's just check 1, 2, 3, 5, 6, 7, 8, 10, 11, 12. 12 parts in the whole. So look in here, let's just check with using some maths here. So we've got 1/4 and 2/6. Now, if I times this by 2, I'll get to 2. So I need to do the same to the bottom. Let's change to a different colour here. Times that by 2. 4 times 2 is not 6. It would actually be 8. So A and B, they're not equivalent to each other. Let's stick with 1/4 here. So 1/4, and then we've got 3/12. Now, top number, you're going to times by 3, because 1 times 3 equals 3. The bottom number, because it's equivalent, we're going to do the same. So we're going to times by 3. So 4 times 3 is 12. So we have found our two equivalent fractions there. It would be A and C. Also, if you had your ruler or piece of paper, you can hold that up to your screen and you can see clearly that A and C are equivalent fractions. And now on to our first reasoning question. As you all know, this is my favourite type of questions I like to do in maths. So Tess is investigating equivalent fractions. She says the next equivalent fraction will be 6/8. She already has two fractions there. So have a go at home and try and find the pattern between those two fractions and work out what the next fraction would be. Then work out is she correct and make sure, because it is reasoning, that you explain your answer. So like I did on the first one, I'm going to write out the fractions, each the two shapes there on the screen. So the first one would be 2/3, and then we have 4/6. From here, I can see, I can do a bit of maths, I can do a bit of trial and error. I can see, is it divisible, dividing by 1 of each? No, it's not. How about dividing by 2? So we've got, let's write it up here. And 4/6. So if I divide that top number by 2 and that one by 2, it shows it's equivalent. You can see it's equivalent as well. You can use your piece of paper and find it's equivalent. But she says the next one is 6/8. Now let's just check. So if that was times in by 2, our next one, so 2/3, would be multiplied by 3, because that's the next number in our pattern, which is going up in 2, 3, 4, that sort of pattern there. So we've got 2/3. Now we're going to multiply that by 3. We can do that to both our top and our bottom, because we're finding our equivalent fractions. So 2 times 3 would be 6. So she's got the first, but she got the numerator right. And then 3 times 3 is 9. So she has not got the denominator right. So Tess would be incorrect, because 3 times 3 is actually 9 for the denominator, not 8. And for our next question, it's a problem-solving one, and you need to find the fraction that is the odd one out. First of all, I'd like to have a go at home, and then I'll explain to you which one is the odd one out. So just like with the other questions, I would write the fraction out for each of these drawn on shapes here. Just for me, it really helps me seeing all the fractions there in context. Don't know if that's the same for you, but that's just something I like to do. So this top number here is 3/6. It's got 6 parts in total, and 3 of them are shaded. Our next one shaped here on the right is 6/12, because there's 12 parts in the whole, and 6 are shaded. And our last one down here is a half. Now, I would now be looking for patterns, seeing which ones are equivalent, which ones are not equivalent, and going through that way. So let's start with our 2/3 up here. So we've got our 2/3. Let's see, it's equivalent to 3/6. One way we can check is we could divide each number by 2. So we know, ooh, mouse went a bit wrong there. So we've got 6 divided by 2 is 3, so the denominator would be correct. 3 divided by 2, that doesn't equal 2, so they're not equivalent. So that doesn't work for our pattern here, or what we're trying to find. Let's get rid of all of this. So next let's say we have our half here, and working with our 3/6. Now we could times numerator by 3, which gets to the 3, and then do the same to the bottom, which times by 3. So they're the same. 1/2 and 3/6 are equivalent fractions. which you can then say, let's try 6/12. So let's put 6/12 over here. Let's times that top number by 6, because 1 times 6 equals 6. Do the same to our bottom number. So 2 times 6 is 12. So they're also equivalent fractions. So it would seem that our odd one out is our 2/3, because half, 6/12, 6/12, and 3/6 are all equivalent to each other. And for our last question today, Cara is investigating equivalent fractions. She thinks she's made equivalent fractions, which you can see there on the screen. Is she correct? Prove it. Now I'm going to use my piece of paper, and instantly I can see that she is incorrect. But however, this is a reasoning question, and we need to make sure we can prove it. So have a go at home and see where is she gone wrong. Just like with the other questions, I'm going to write the fractions next to it. Like I said before, that just helps me answer the question. Luckily, it may not help you, but if it does, that is fantastic. So our first fraction up here, we've got 4 parts in our whole, and 3 are shaded. And our bottom number down here, there are 7 parts make up the whole, and 6 are shaded. So again, like with the other slides, I'm going to use some multiplication or division just to check where she might have gone wrong or what the equivalent fraction should have been. So let's start off with our 3/4, and we've got our 6/7 here. So first of all, I'm just going to divide top number by 2, because I know 6 divided by 2 is 3. And let's do the same to the bottom number. So 7 divided by 2 would not be 4. So where has she gone wrong? Let's do a bit of inverse here. So if we know that the top number, our numerator, is divided by 2, let's change that to times by 2, so that 3 times 2 is still 6. And then, because we've done that to the top number, we need to do the same to the bottom number. So 4 times 2, which is not 7, it would actually be 8. Because 3/4 is actually equivalent to 6/8, not 6/7. Fantastic, great work there. Have a go at the challenge sheets on the website, and if you have any questions, please email your class teacher. And most of all, hope each and every one of you have a great day.